Yes, good afternoon, guys. Welcome to the lecture one, revision lecture one of hydraulics and hydraulic machinery. So, we had this subject in the second year, second semester. So, because of this exams to be conducted soon, so we are starting the revision classes. Actually, we have actually completed the 90% of the portion last semester. So, in this week till Saturday or Sunday, so I will give a brief lecture about all the units. Okay, so classes కొంచెం fast గా ఉంటుంది, right? So these classes will be fast when compared to your normal classes. Why? Because you are having less time, so that I will complete all the 6 units in brief, not in detail. మీకు ముందు నెక్స్ట్ మేనేజ్మెంట్ సైన్స్ సబ్జెక్ట్ ఎంత డీటెయిల్గా చెప్తున్నానో, so I will not discuss, I will not give that much detail. So for every unit it will take about 2 lectures or maximum 3 lectures. So within 2 or 3 lectures I will complete 1 unit, so that by Saturday or Sunday we'll complete all the 6 units in offline or online, right? So today we'll complete 1 unit. So lecture 1 is one class, lecture 2 will be other class. It will be started around 4 o'clock. Okay, why? Because I have 3 p.m. I have a second year mechanical. So at the 4 p.m. again you are having second lecture, the unit 6, right? Okay. So coming to the syllabus, so we are having unit 6, centrifugal pumps and reciprocating pumps. So whatever the topics we have discussed earlier in the physical class also, we will discuss here also, right? So I will give all the information briefly, not in detail. Once again I'm saying you, I am giving the information not detailedly. So within 2 or 3 lectures I will complete every unit, so that 6 units will be completed by Sunday. Meanwhile, I'll give the important questions, the mid question important questions also, so that you can learn the questions and you can write the second mid exam also, right? And also I'll send these PPTs to your group, so that you can see the unit wise PPTs, right? So there will be no problem. Okay, so in the centrifugal pumps you are having the classification of the centrifugal pumps, right? How the pump installation takes place, classification of the pump, work done efficiency of the pump, the manometric head, minimum starting speed, losses of the pumps, efficiencies of the pumps, and specific speed of the pumps. So here also you're having problems. So I will discuss only 1 or 2 problems. Balance problems you have to learn by yourself, right? So because of no time, so I will take 1 day, 1 unit. Next one is multi-stage pumps. Pumps in parallel, pumps in series, performance of the pumps. Next one is characteristic curves, NPSH, cavitation and their problems. So already దీని గురించి డిస్కషన్ మనం ఆల్రెడీ చేసాము రెగ్యులర్ క్లాసెస్లో. సో నెక్స్ట్ క్లాస్ ఆర్ దిస్ క్లాస్, నెక్స్ట్ క్లాస్ నుంచి మీరు టేక్ యువర్ రన్నింగ్ నోట్స్ ఆల్సో. వాట్ ఎవర్ ద రన్నింగ్ నోట్స్ యూ హ్యావ్ రిటన్ ఇన్ యువర్ క్లాస్ వర్క్, ఆ రన్నింగ్ నోట్స్ కూడా మీరు ముందు పెట్టుకొని ఒకసారి రెఫర్ చేసుకోండి, so that it will be very easy for you to recollect the topics what you have got in the class. Okay, so I have got 6 students. So if you have any doubts, so that you can unlock your mic and you can talk to me. Okay, so I'm starting the class. First concept is the centrifugal pumps. So the textbooks, I will give the soft copy, don't worry. So these are the textbooks, so that you can follow for this centrifugal pumps, right? Not only centrifugal, all the units what you are covering. So see the physical centrifugal pump, how they are looking like, right? So these are the centrifugal pump. Inside you are having a motor. This is a motor, right? This is the inlet. This is a outlet. This is the inlet. This is a outlet. So this is a motor. That is the one side inlet. This side outlet. So inlet, outlet. So pump, you are having a motor assembly like this. So this is the physical setup, the physical configuration of a centrifugal pump. Now, what is the meaning of centrifugal pump? Concept is from the center of the circle, from the center of what is the centrifugal? What is the meaning of centrifugal? So from the center, it is moving away. It is moving away to the circumference of the object or a circle. A machine for moving fluid, a machine for moving fluid by accelerating. Yes. Okay. The machine for moving the fluid by accelerating the radially outwards. So it is pumping the water radially outwards, pumping the water radially outwards till the circumference of the casing. So that is the concept of centrifugal action, radial direction to the outside of the circle. Okay, next. So if you see the figure of the centrifugal pump, this machine consists of impeller rotating with the case. So inside you are having this type of impeller. So I will show you the impeller. So once the water is going in this direction, see the direction of the water. Once the water is going in this direction, because of this rotation of the impeller, water is spreading outside. Water is spreading outside. It is going towards center and water is spreading outside, right? So the liquid directed into the center of the rotating impeller is picked up by the impeller vanes. So what are this one? Vanes or blades. We are calling this as a vanes. So these vanes, what they will do? They will flush the water outside in a radial direction. The vanes accelerated to the higher velocity by the rotation of the impeller and discharged by the centrifugal force into the case. That is the concept of this centrifugal pump. So when you see the pump terminology, so మీకు చూపించిన first figure లో this one. So the first figure, the line diagram. See here. So this is the inlet. So this is the water is going inside like this. Okay, the water is going inside like this and going into the impeller. So this one is the impeller and this one is the vanes. See here, the eye of the impeller. These are the vanes of the impeller. So once the water is going in one direction and going into the impeller by the help of the vanes, it will flush away radially outside the water, just as shown in the previous slide like this. Okay, so it is coming out and passing in the direction of the casing and it is moving upside. So if you got any question like draw the line diagram of pump, you can draw this figure. This is a flange, this is a volute, this is an impeller, this is a vanes, this is of the eye of the impeller, this is the inlet, right? So a collection chamber in casing converts much of kinetic energy into the head or pressure, right? So that is nothing but the simple concept of centrifugal pump. Next, the collection chamber in a casing converts what much of the KE into the head pressure. So then what is the meaning of head here? Head is a term of for expressing feet of the water column. Head can also be converted into pressure. Head can also be converted into pressure. You see the simple line diagram for a tank. So if this is a reservoir fluid, so where it is containing the reservoir. So the pressure gauge. So whenever the water is full in a tank, you can see the pressure gauge is 43.3 psi. Just is a example for this reciprocating pump. The head and the pressure are interchangeable terms provided that they are expressed in their correct units. The conversion of all pressure terms to the units equivalent head simplifies most pump calculations. Now if you see the centrifugal impellers, centrifugal impeller, so you can see the centrifugal impeller, the figure like this, that these are the impeller vanes, right? This is the eye of the impeller, water entrance, అంటే వాటర్ మనకి ఈ డైరెక్షన్ లో ఇట్లా లోపలికి వెళ్ళినప్పుడు because of this pressure, because of this impeller is moving, thereby the water is flushing outside through the veins. So diameter of the impeller, thickness of the impeller, the thickness of the impeller is equals to more water whenever you are keeping. The larger the diameter, the pressure will be more, right? More water, thicker the impeller, and more pressure, larger diameter. If the increase in the speed, more water and pressure is required. So whenever you are, that's why if you go and ask any shop centrifugal pump, if you simply ask a pump, they will say which type of pump, reciprocating pump or centrifugal. If you ask a centrifugal pump, again they will say what is the capacity, right? 3 HP, 1 HP, 1 HP, 2 HP. So like this they will ask because of this specifications of the impeller. Understood? Next, if you see the two impellers in series, so if you see the two impellers in series, so the direction is going like this, the water is going like this. So the direction of the flow will be in this direction. So whenever the impeller is large, the diameter is large, automatically the pressure will be also increased. So if you see the multiple series, so this is the figure. Placing impellers in series increase the amount of head put used, right? So whenever the impellers are placed, just like a multi-stage centrifugal pumps laga. So I will show this slide in the next slides. So then what is the simple meaning of a pump? Say a pump is a hydraulic machine which converts mechanical energy into the hydraulic energy. So simple concept గుర్తుపెట్టుకోండి. A pump is nothing but a mechanical pump is nothing but a machine which converts mechanical hydraulic energy or pressure energy. Pump is also known as rotodynamic pump or dynamic pressure pump. So for a centrifugal pump, you are having two names. One is rotodynamic, other one is a dynamic pressure pump. It works on the principle of centrifugal force. In this type of pump, the liquid is subject to the whirling motion. Whirling motion means మీరు ఫర్ ఎగ్జాంపుల్ ఒక బకెట్ ఆఫ్ వాటర్ లోపల చేయబెట్టి జస్ట్ బాగా సెంటర్లో బాగా తిప్పండి. సో తిప్పి వదిలేస్తే ఏం జరుగుతుంది? యూ విల్ గెట్ సమ్ సార్ట్ ఆఫ్ whirling action, right? By the rotating impeller, which is made a number of backward curve vanes. The liquid enters into the impeller at this center or eye and gets discharged into the casing enclosing the outside edge of the impeller. This sentence you can write on your own whenever you get a question. Generally, the centrifugal pumps are made up of radial flow type only, right? So generally, axial కాకుండా ఇది మనకి ఎలా ఉంటుంది? Radial flow type of pumps. But there is also some type of axial flow or propeller pumps, depends upon the applications and low heads, right? So for a radial pumps, you are having a high head, and for axial flow and propeller pumps, you are having low heads. So if you see the basic structure, simple volute centrifugal pump cross section, you can draw the simple figure like this, right? So if you see the one more extension of this centrifugal pump, you can see this type of figure, right? So this is the inlet of the water. The water is going in this channel. So you are having a rotating shaft. So the shaft is rotated by the motor. You are having a fan blade. It is rotating radially. Thereby, with this fan blade rotation, the water is going in this direction and in this direction, right? See the types of impellers, right? Here you are having open type of impeller. Here you are having semi-open type impeller. Here you are having closed type of impeller. Simple diagrams so that you can easily understand. So impeller ekkada untundi? Ee center lo untundi, right? Next, what are the advantages of the centrifugal pumps? Total, yes, 7 students. So what are the advantages of centrifugal pumps? So the centrifugal pump cost is low. Initial cost is low. Efficiency is high. Simply, we draw you get any question in the exam, simple sentence, you can close it. Initial cost is low when compared to reciprocating pump. Efficiency is high when compared to reciprocating pump. Discharge is uniform and continuous, and installation and maintenance is very easy, and it can run at high speeds without any separation of flow, right? Next, what are the classification of the centrifugal pumps? ఇప్పుడు నేను చెప్తున్న టాపిక్స్ అన్ని according to your syllabus only, right? Centrifugal pumps may be classified into the following types. So first one ఏంటి, according to the casing design. Casing అంటే ఏంటి, దాని పైన ఉన్న లేయర్. So if you see your pump, yeah, yes, some technical problem. Okay, this is a casing of a centrifugal pump. Next, so the centrifugal pump, according to the design, you are having, first one is volute type pump, other one is a turbine type pump. Okay, second one is according to the number of impellers. So according to the number of impellers, you are having single stage pumps, multi-stage impeller pumps. Next, third one is according to the number of entrances. Any entrance lunayi. First one is single suction pump and double suction pump. What is the fourth classification? According to the disposition of the shaft. So you are having horizontal position and vertical position. Next one is according to the liquid handled. What type, how you are handling the liquid, semi-open or open type of impeller. Next, according to the specific speed, you are having low specific speed, medium specific speed, and high specific speed. Seventh one is according to the head, manometric head. Low head, that is less than 15 meters, medium head in between 15 to 40, high head more than 40 meters. So totally you are having 7 classifications of centrifugal pump. So keep this in mind. Advantages, classification of centrifugal pumps. So if you see the general layout of the centrifugal pump, so for example, మీ ఇల్లు తీసుకోండి. So in your house you are having a water tank at the top of your house and a well in the front of your house. Okay, so whenever you are having this type of system, so this is your sump, this is your water tank at the top of your house. So how you are getting the water? So this is separate installation. So you are having here filter, so pipe, so the water is coming from here. So this is at the top, at the flat surface of your ground of your house. So on the flat surface, so you are arranging a pump, right? So one pipe is connected to the inlet, other pipe is connected to the outlet. So whenever you switch, motor rotates, the shaft rotates, the shaft is connected to the impeller shaft, thereby the impeller rotates, thereby the water is going into this pipe, and through these valves you are opening, closing the valves, thereby the water discharge, the water flow will be high or low, you can decide it. Thereby the water is going in this direction and you are filling your tank. This is a general layout of any pump. Simple ga గుర్తుపెట్టుకోండి. Next, coming to the components of the centrifugal pump. The main components of the centrifugal pump are, first one is impeller, second one is casing, third one is suction pipe, fourth one is a foot valve with strainer, fifth one is a delivery pipe, and sixth one is a delivery valve. So these are the 6 main components of centrifugal pump. Coming to the impeller, it is a rotating component. ఇందాక మనం చెప్పుకున్నట్టు rotating component of a pump. It is made up of series of curved vanes. The impeller is mounted on the shaft connected to the electric motor. So మీరు ఈ థియరీ అంతా కూడా చదవాల్సిన అవసరం లేదు. Simply you can write on your own. So if you see, once ఈ క్లాస్ అయిన తర్వాత go outside of your house, లేదంటే మీ ఇంట్లో ఎక్కడన్నా కార్నర్లో మోటార్ ఉంటే దాన్ని ఒకసారి చూడండి, మీకు ఒక ఐడియా వస్తుంది how it operates, right? Second one is casing. It's an airtight chamber surrounded the impeller. The shape of the casing is designed in such a way that the kinetic energy of the impeller is gradually changed to the potential energy. So how it is designed? So kinetic energy of the impeller is gradually changed to the potential energy. This is achieved by gradually increasing the area of the cross section in the direction of the flow. Next, suction pipe. It is a pipe connecting the pump of the sump. So suction pipe అంటే ఏంటి? It is a pipe connected to the pump to the sump. Pump ki sump ki you are making a engagement, that is a suction pipe, from where the liquid has to be lifted up. Okay, na? Next, foot valve with a strainer. The foot valve is a non-written valve which permits the flow of a liquid from the sump towards the pump. In other words, the foot valve opens only in upward direction. It is a non-written valve. The strainer is a mesh surrounded by the valve. It prevents the entry of the debris and waste material or some other dust particles present in the water or silt into the pump. So what is the purpose of this mesh ante? So మీరు బావిలో కానీ సంపులో కానీ ఆకులు చెత్త ఏమన్నా ఉంటే it will collect there only. Next, delivery pipe. It is a pipe connected to the pump to the overhead tank. Delivery valve. It is a valve which can regulate the flow of the liquid from the pump. So hope you are understanding why, because I'm saying a little bit faster, but there is no time, so you have to understand. That's it. So this is a simple layout, not a simple, complicated layout of a centrifugal pump. So how does the centrifugal pump action takes place, right? So this is a suction nozzle where it is going in, it is going out. So the total mechanical figure of the centrifugal pump, you can see here. The water is going inside, the discharge nozzle is water is going outside. This is a mechanical, this total one is a mechanical setup. Okay, next. So if you see the impeller cavitation regions, so you see the impeller cavitation, so the 3D figure. So it is a thermal stresses, blue color, red color. So if you see the cavitation regions, cavitation in the question, the cavitation means small holes that occurs on the veins, vein trailing edge. So whenever the vein is rotating in this direction, so what happens due to the collapsing bubbles, due to the formation of bubbles, so what happens at the edge Tande, because of this collapsing bubbles takes place, the edges will get some sort of cavitation. So cavitation we'll discuss in the next coming slides. Then priming. What is the meaning of it? Priming of the centrifugal pump. Priming of a centrifugal pump. Priming means the process of filling the suction pipe casing of the pump and the delivery pipe into the delivery valve with the liquid to be pumped. If the priming is not done, the pump cannot deliver the liquid due to the fact that head generated by the impeller will be in terms of meter of air, which will be very small. Because of this, what happens? Specific weight of water is very much smaller than that of the water. So the priming is a process of filling of the suction pipe, casing, pump, and the delivery pipe up to the delivery valve with the liquid to be pumped. So that is nothing but priming of the centrifugal pump, right? So simply we can say whenever you are not, when you switch on the motor, whenever the water is not going from sump to your tank, what you will do, you will stop the motor, you will open the valve and you will pour some water so that the water will fill to the suction pipe casing of the pump and the delivery valve. So మీరు పోసి నింపుతూ ఉంటారు, వాటర్ లోపలికి వెళ్ళాలి, అన్ని ఛానల్స్లో వెళ్ళి మీరు ఒక 1 bucket 5 mugs 10 mugs పోస్తున్నప్పుడు whenever the water comes outside and stores there, then you can realize that we can switch on the motor. That is nothing but the priming of the pumps. Next, coming to the what are the various methods to be followed on the priming of the pump. First one is priming with the suction or vacuum pump, priming with a jet pump, priming with the separator, automatic or self priming. This is the various methods we are using for priming of the centrifugal pump. Next, coming to the various heads of the centrifugal pump. Okay, so the first one is a suction head. So these are used for your problems. Suction head, it is a vertical distance between the liquid level. Vertical distance is the vertical distance between the level in the sump and the center line of the pump, expressed in meters. Suction head ఏమంటున్నాము? HS అని చెప్తున్నాం. Next, delivery head HD. It is the vertical distance between the center line of the pump and the liquid level of the overhead tank or to the supply point. It is also expressed in meters. Next one is static head HS. It is a vertical distance between the liquid levels in the overhead tank of the sump and the sump when the pump is not working. It is also expressed in meters. Therefore, static head HS is equals to HS plus HD. This is the formula, right? So formulas and మీకు separate ఒక slide ఉంది, don't worry. Next, friction head HF. It is the sum of the head loss due to the friction in the suction and the delivery pipes. So by taking this friction, the Darcy-Weisbach formula, HF is equals to FLV square by 2GD. Then next one is a total head. It is the sum of the static head, friction head, and a velocity head in the delivery pipe, where Vd is equals to velocity at the delivery pipe. Therefore, total head HM is equals to, what is HM? Suction head plus delivery head plus friction head plus V square Vd square by 2G. Next one is manometric head. It is a total head developed by the pump. This head is slightly less than the heat generated by the impeller due to the some losses in the pump. Therefore, HM is equals to H plus V square by 2G minus Vd square by 2G. Next one is work done by the centrifugal pump on the water. So how whenever the water is pumped into the centrifugal pump, so the water goes into the pipe in the inlet, and through the impeller it is flushing through the veins and coming outside. So whenever the water is acting on the vein, see here vein, whenever the water is acting on the veins, how it will takes the work done flow. For example, see here, if we take a portion, the velocity triangles at the inlet and the outlet. So ఒకటి మనం ఇన్లెట్ అనుకున్నప్పుడు, if other one is outlet, at the outlet and the inlet we are making some velocity triangles. Already మీరు చేశారు మీరు. So we are making some velocity triangles and we are solving some of the formulas and derivation. So how does the work done? So if you see here, the inlet and the outlet. So the rotation is like this. The tangent to the inlet, tangent to impeller at outlet, tangent to the impeller at inlet, right? So in the centrifugal pump, work done is done by the impeller of the water. The expression for the work done by the impeller on the water is obtained by drawing velocity triangles at inlet and outlet of the impeller. The water enters the impeller radially at the inlet. The water enters the inlet radial at inlet for the best efficiency of the pump, which means absolute velocity of the water at inlet makes an angle of 90 degrees with the direction of the motion of the impeller at inlet. Hence, angle alpha is equals to 90 degrees. For drawing the velocity triangles, the same notations are used for the turbines also. So if you see from the figure, let n be the speed of the impeller in RPM. D1 is the diameter of the impeller in diameter at the inlet. U1 is the tangential velocity of impeller at inlet. So thereby, by taking this one, so the velocity is equals to pi dn by 60, where is d2 is the diameter of the impeller outlet, u2 is the tangential velocity, therefore velocity is equals to pi d2 n by 60. So here v1 is absolute velocity of inlet at inlet, vr1 is equal to relative velocity. ఇవన్నీ మీరు ఒకసారి మీరు నోట్స్ లో రాసుకున్నారు, జస్ట్ you check your notes. Okay, next alpha is the angle made by the absolute velocity, theta is the angle made by the relative velocity. In the same way, v2 vr2 beta and pi are corresponding values at outlet. Simple ga em cheyalante just by heart or just practice this. So whenever you get any question, determine the work done by centrifugal pump అన్నప్పుడు, so just by heart or practice this figure so that inlet కి వచ్చేసి అన్ని టీటా ఆల్ఫా v1 u1 vf1 వస్తుంది, అవుట్లెట్ కి వచ్చేసి v2 vf2 గామా beta pi vf2. So like this you will get, right? So based on that అవన్నీ మీరు you have to mention it. Thereby the work done is equals to 1 by g Vw1 u1 minus Vw2 u2. Therefore, per second is equals to minus into work done in case of turbine. So after doing this all derivation, so ఇవన్నీ మీరు ఆల్రెడీ చేసాం, ఒకసారి చెక్ చేసుకోండి. సింపుల్, వెరీ సింపుల్. సో Q discharge is equals to area into velocity of the flow. Area వచ్చేసి pi dp into Vf1, that is equal to ID2 B2 into F2. So ఇది వచ్చేసి ఇన్లెట్ కి, ఇది వచ్చేసి అవుట్లెట్ కి. Therefore this equation, these are the two equations for the discharge, right? So next one is efficiencies of the centrifugal pump. Efficiencies of centrifugal pump. So you are having three types of efficiencies. So in case of centrifugal pump, the power is transmitted from the shaft to the electric motor. The power is transmitted from the shaft to the electric motor to the shaft of the pump and then to the impeller. From the impeller, the power is given to the water. Thus, the power is decreasing from the shaft to the pump and impeller then to the water. Thereby, the important efficiencies of the centrifugal pump are: first one is manometric efficiency, second one is mechanical efficiency, third one is overall efficiency. What is the first one? Manometric efficiency. So this is a symbol. The ratio of manometric head to the head imparted by the impeller to the water is known as manometric efficiency. Therefore, N man is equals to manometric head divided by head imparted by the impeller to the water. So then what is the formula for manometric efficiency? HM divided by VW2 U2 by G, that is equals to G into HM divided by VW2 U2. So this one. Next. So if you see the power of this one, WHM by 1000 into kilowatts, the power of the impeller is work done by the impeller per second divided by 1000. Therefore, W by G into WV2 into U2 by 1000 kilowatts. So that implies N manometric efficiency is equals to, just write this one, W into HM by 1000 divided by this one. So next, the second one is mechanical efficiency. Mechanical efficiency. The power of the shaft, the power at the shaft of the centrifugal pump is more than the power available at the impeller. The ratio of the power available at the impeller to the power of the shaft of the centrifugal pump is known as mechanical efficiency. Therefore, mechanical efficiency is equals to power of the impeller divided by power of the shaft. Okay, power of the impeller by power of the shaft. The power of the impeller is work done by the impeller per second by 1000. Already ముందు మనం చెప్పుకున్నాం. Therefore, W by G into VW2 U2 by 1000. Therefore, manometric efficiency is equals to power of the shaft and power at the impeller into, this is the power of the impeller, then divided by SP. What is SP here? The power at the shaft power. This one. Next, overall efficiency. Third one is overall efficiency. It is defined as a ratio of power output to the pump to the power output to the input of the pump. Therefore, overall efficiency is equals to manometric efficiency into mechanical efficiency. So in this unit, so majority will get 40% theory and 60% problems, right? So 40% theory, 60% problems. So maximum unit 5 మీరు బాగా నేర్చుకోండి. So when you come in your final exams, so unit 5, unit 6, unit 5 and unit 4, కొంతమందికి అది ఈజీగా ఉండొచ్చు, కొంతమందికి యూనిట్ 1, 2, 3 ఈజీగా ఉండొచ్చు. బట్ టు స్కోర్ సమ్ గుడ్ మార్క్స్, యూనిట్ 6, 5 తరువుగా ఉండండి, రైట్? సో ద ప్రాబ్లమ్స్ కూడా మనము డిస్కస్ చేసాము. So these are the some of the problems. So I'll give the slide slowly. So 3 o'clock, 3 to 3:40. Okay, 3 to 3:40. So you are having a class at 4 o'clock again, right? So 4 o'clock session will complete the unit. Okay. So see the problems here. Okay, problem chapter remaining problems you practice on your own. So the internal and the external diameters of the impeller of the centrifugal pump are 200 mm and 400 mm. 200 mm and 400 mm. The pump is running at 1200 rpm. The vane angles of the impeller and outlet are 20 degrees and 30 degrees. The water enters the impeller radially and the velocity flow is constant. Determine the work done. So first write the give. So not only in this unit, total HH, not only in the hydraulics machinery, in any subject, whenever you are getting problems, first మీరు question 2 times చదవండి minimum. So when there is any drawing figure, just draw the figure మీకున్న knowledge తో. First write the given data. So that you will get minimum 2 marks. But the question paper, once you write the answer for any question problem, externals లో పేపర్ కరెక్షన్ ఎవాల్యుయేషన్ ఎలా ఉంటుందంటే గివెన్ డేటాకు 2 మార్క్స్, ఫార్ములాస్ రాస్తే 2 మార్క్స్, ఫిగర్ వేస్తే 2 మార్క్స్, మ్యాటర్ సాల్వ్ చేసినందుకు ఒక 3 మార్క్స్. లైక్ దిస్ దే విల్ ఎవాల్యుయేట్, దే విల్ బి ద ఫుల్ మార్క్స్. ఇఫ్ యూ రైట్ ద ఆన్సర్ ఒక పాయింట్స్ లో తేడా వచ్చినా, యూనిట్స్ మీరు చేంజ్ చేయకపోయినా, exact answer రాకపోయినా, there is no problem. But how you are doing the problem, what formulas you have written, that is important. So if you don't know anything about any problem, first read the question 2 or 3 times, understand it, write the given data neatly, clearly write the given data like this. So based upon this one, to find AND, to find work done. So to find and rasi work done of the impeller to be determined and రాసేసి మీకు నచ్చిన మ్యాక్సిమం ట్రై చేయండి. సో డి ఉంది కాబట్టి సింపుల్గా మీరు యు వెలాసిటీ యూడిఎన్ బై 60 అట్లా వేసుకుంటూ వచ్చేసండి, రైట్? సో వాట్ ఎవర్ ద ఫార్ములాస్ యూ నో రిలేటెడ్ టు దిస్ క్వశ్చన్, రైట్ సమ్ ఫార్ములాస్ అండ్ రైట్ సమ్ ప్రాబ్లమ్స్, సో దట్ ఆన్సర్ రాకపోయినా ఎంతవరకు రాస్తారో అంతవరకు రాసి వదిలేయండి, ఫిగర్ ఉంటే వేయండి. సో దట్ యూ విల్ గెట్ 2 + 2 + 2 మినిమం 5 or 6 marks instead of 8 marks, right? So there is a simple logic behind the problem. But problems to me as it is రాసి వదిలేయద్దు. Minimum write the given data, write the figure, write minimum calculations. Next, minimum speed. So ఈ ప్రాబ్లం నేను చెప్పట్లేదు because of no time. Only 2 minutes left. మీరు చూసుకోండి ఒకసారి. Minimum speed for starting of the centrifugal pump. Yes, any problem? Okay. So if you see the minimum speed, so here the minimum speed is equals to so this is a minimum starting speed of centrifugal pump based upon this centrifugal pump formulas. You are having some minimum problems. So these are the simple problems so that you can easily check out the problems. Okay. Centrifugal pump problems, vane problems. Okay. So next one is a multi-stage pumps. Next concept is multi-stage pumps. So this is a multi-stage pump. See how the figure is. So the multi-stage pump setup. So if you see the 3D figure, see inside how the multi-stage pumps. So these are the outlets, inlets, outlets, inlets. So there's a long shaft. So you're having, it is rotating by the means of this devices.